Merhaba arkadaşlar. Hoş geldiniz. Biraz I believe we can start. One. Okay, let's start then. Thank you for coming here. It's a pleasure to be here with you and share my knowledge with you. I hope you will enjoy, and thank you for attending this session. I hope it will be interesting for you. And before we start, let me introduce myself. My name is Dmitry, and I am a software engineer with over 10 years of production experience in software development. And I have started my career path as a student. When I was in university, I have joined in EPAM, and then step by step, junior, middle, lead, I have improved my skills as Java engineer. And currently I'm working as a software solution architect in EPAM systems. And last years and last my projects, I'm mostly focusing on transformation monolithical applications into microservices. At the same time, I'm very interested in cloud applications, in cloud native applications. And today's session, I wanted to make a little bit in interactive mode. From time to time, I'll ask you some questions, and I expect some feedback from you. It was very hard day today, I understand, and I'll ask you to find some energy. Do not sleep, please, because I hope it will be interesting for you. And before we start, my first question to you, does anyone have a cat? Cool. Why am I'm asking it? Because I love technologies, and I try to use these technologies everywhere. And I have two cats. One of them Kotlin, one of them is Java. And yes, they are very beautiful, I hope. Okay, and let's start with my talk. Today I'm going to talk about cloud native. Cloud native definitions. We will review the cloud native misunderstanding, and actually we will talk about Java and how Java adopted to the cloud and what kind of capabilities we have in scope of Java. So let's start. Let's keep the agenda, time is limited. Let's start from the business, because any application, any product starts from the business requirements and expectations from our customers. And as you know, nowadays, our customers, our clients has high expectation than they had earlier, because they saw very beautiful applications. They some kind of accustomed to these high standards by impressive these applications and web pages which another companies provide and create. And as you know, maybe our customers think that implementing and designing such application, it's easy. They expect that solution that we will provide won't have any bugs, but if we will have some kind of bugs, they should be fixed immediately. At the same time, they expect to have very good super user experience. But this is not easy for us to implement. And based on this high customer expectation, we get resulting with the business challenges. For example, our customers expect this level of expectations, but at the same time, we shouldn't exceed the provided budget. we some kind of need to predict the business growth and how the company will grow and how IT technologies will help to this company and increase the delivery and so on. We should also do not forget about features which customer would like to see and which will appreciate, and this is very important thing. And at the same time, time is also always limited, and they ask us to reduce these times. This is again the challenge for us. Except of business challenges, which we had the bottom one, we have some kind of technical challenges, because we don't know, we would know predictable high load to our applications. Customer expect high reliability, and usually customer expect to support frequent updates and changes. And cloud native indeed is really answering to this demand, because cloud native can fight with all these challenges and provide all needed capabilities which our customers would like to see. But for create these kind of applications, it will be some kind of challenge for the business, for the company itself, because they need to change the mindset. Because we had for a long time some kind of environment which doesn't provide us all capabilities which we require right now. And this is big technical transformation to the company, and they should change mindset, they should change the technologies, and development lifecycle also should be changed. If we would like to create modern applications and so on, or transform them, we should to adopt new techniques, for example, low code, no code, and it's also some kind of transformation for our clients. And cloud providers which we are using right now somehow provide all required services, and we can use them. And now let's talk about the cloud native definitions. And you know, in EPAM we have worked with my colleagues to define what the cloud native. And a lot of my colleagues highlight that cloud native definition from Cloud Native Foundation is the best one. Why it's the best one? Because it's provide us all required needs which we need to implement the scope of cloud native applications. What Cloud Native Foundation says, that we need to build and run scalable application in the cloud. And this application should be loosely coupled system, they should be resilient, manageable, observable, and so on. And also they should support these frequent changes, because our world changing very frequently. And based on this definition, and can you see, cloud native definition, it's not about technologies at all. Cloud native definition says that technologies which we are using right now, they just exemplifying cloud native approach. It means that all these containers, service meshes, microservices, APIs which we are using today are currently and actual today. And we don't know what will happen next month, next year. Maybe next month or year we will have some kind of robots-driven API or AI-driven development. And all these things could be a part of this picture. It means that technologies which we are using are changing very frequently. And cloud native definition, it's more about the cloud quality attributes. Like we already talked, loosely coupling, scalability, manageability, observability, and all others. And I would like to highlight here that cloud native is some kind of a world with some kind of rules. And all these rules, these are our quality attributes. And if we would like to live in this world, we need to follow these rules. And if we would like to create cloud-native application, we should follow these quality attributes. And this is a very important thing. And as you know and understand that cloud journey never ends. And technologies which we are using changing all the time, but cloud native and properties, quality attributes of cloud native is remain. And as you remember, we have started with virtual machines. Then we have started deploy these machines to the cloud. We have started to implement microservices, serverless approaches. This is some kind of approaches which change years and years, and we don't know next year what will happen. Maybe after serverless, we will have some kind of another technology. And it means that this world and technology is changing all the time. And does anyone already use serverless applications or build serverless? One people? Good. 2, 3? Cool, cool. Who is already creating cloud-native applications? Or target? Okay, good. One, 2 people. Why am I'm asking this question? Because there are a lot of misunderstanding regarding cloud-native definition. Because if we'll ask, for example, 10 software engineers, they will provide us 10 different definitions of cloud-native. And with next slide, I would like to give you some kind of short overview about these misunderstandings. For example, let's start with cloud optimized. Some people says to his product that they are cloud native, but if we will deep dive into this application, we understand this just cloud optimized. What does it mean? Client had some kind of on-prem application, and we are lift and shift approach. He would like to adopt the cloud, adopt his application to the cloud, and he can make some changes or do not change anymore, and they starting building his application to the cloud, but it's some kind of migration and optimization. And after all these steps, does it mean that this application become a cloud native? But actually no, because this is just the optimization of your application. This is still all your old application. It still leverage all traditional approaches and development approaches and so on. Next one is cloud enabled. Also some people talk to this like cloud ready. It's also another approach of lift and shift. When product was built with traditional way, and these clients target this application again as cloud native. But unfortunately, this still is not a cloud native application. This is just cloud enabled applications. Next one, very interesting, and I hope someone you already leverage Kubernetes here. And some people says that we are building application we deployed into the Kubernetes. We can run this application everywhere. And they says that we are cloud native. But again, if we'll deep dive into this talk, we can see that this is not some kind of cloud native application. It's more like cloud agnostic, because such projects, such application leverage some kind of another quality attributes like portability. they would like to avoid the vendor lock because they would like to build their application not only, for example, AWS, but into the GPC or something else too. They would like to get more control, and it means it's, again, it's not some kind of cloud native, it's more cloud agnostic. But here is important thing that cloud native solutions can be cloud agnostic, but it's not a must. But not every cloud agnostic solution is cloud native. Last one, but not least, cloud first and cloud native. Simple comparison, cloud first means that company focusing only to the cloud. This is some kind of strategical focus. At the same time, on the other hand, cloud native is this approach of implementation of our applications. And via all these slides, I wanted to, again, to clarify that cloud native application, it's not about technologies. It's not about strategy of company. It's all about quality attributes, which we have discussed. And now let's switch to the Java. And as you know, cloud is everywhere, and cloud change everything. And now I would like to talk, is Java adopted to the cloud? And to answer this question, I need to switch to the back to several years ago when we had the traditional Java server. It was some kind of, as you remember, a data center where we have deployed our server. It was a big server. Into this server we have installed our JVM. We have installed our application server, for example, Tomcat or something else, and we deployed our application, Java application. And it could be not a single application, it could be multiple applications. And based on this traditional approach, I can bring here the question, is Java adopted to the cloud? Is Java as technology adopted to the cloud, and is Java frameworks, which we are using right now, can provide us all required capabilities to implement these cloud native applications? And why I am asking all these important questions? Because when boom of microservices happen, or serverless approach, I saw and felt that Java is too complicated and very heavy for microservices approach or serverless approach. And this is some kind of heavy application, and traditional approach which we are using, it's not provide us all these capabilities which are important right now. And that's why I have started to think about and learn some another languages, maybe scripting languages, because at that time when we just started build microservices, serverless approaches, these scripting languages started provide us all required capabilities which we can use right now and resolve all our customers' expectations. And my questions to you, do you already started to learn new language except of Java? Maybe someone already learned Python, Node.js, and other scripting languages, or everyone writing only in Java? Cool. We have several people, but again, important thing here, because I also have started learn another language, because, for example, Python provided me possibility to create these microservices, serverless approaches, functions as a service. And this traditional server bring us the limitations. Yeah. This is not a full list of limitations of traditional approach, and you understand this traditional approach which we used for a long time bring us this limitation, like slow startup time. It was a single container with multiple applications. We had a lot of disadvantages which came from monolithical applications. We had high memory consumptions and so on. And we had this environment for a long time. And that's why we have all these questions about Java. And is Java adopted? And that's why I have tried to create the talk and tell you that Java is still great and good programming languages and very good adopted to the cloud. No worries. Yeah. And with next slide, I'll try to give you some information about why this evolution of Java took some time. Because let's start with the cloud. I believe you saw similar pictures in the internet where we have years and we have big players in the cloud, and we see when AWS was released, GCP, Azure, when Docker was released, when we have started to pay per second. All these things are important, and I would like to tell you why. Because if we'll add some more information to this picture, we see that with popularity of the cloud, our architecture approaches like service-oriented, SaaS, microservices, serverless approaches are also transformed. With popularity of cloud, we have started to move several services to the cloud and create smaller and smaller applications. And our approaches of implementation these applications is also changed. And as you know, one thing, important thing here also, monolithic application is still with us. And now let's switch what was happening with the Java at these years. As can you see, Spring was released at the same year when AWS was released. For example, Spring Boot released when we already started implementation of microservices. And we have all these frameworks which, for example, Micronaut, on this conference I saw several talks about Quarkus, Liberty, GraalVM, and all others. And we have created these frameworks to fill out the gap, a void of Java Cloud. Because I believe most of you leverage Spring Boot, and sometimes this framework doesn't provide us capabilities and options to build these serverless approaches, for example. That's why Spring has started create Spring Native to allow to create start and fast applications. This is very important, and according to my personal feeling, I think that Java was a little bit late in development, and Java frameworks, which we are using right now, was a little bit late when they just started his development. Because, as I mentioned, during these years, we already had another scripting languages. That's why I have started new something. Maybe someone also started new learning another languages. And this was some kind of issue for us. But now everything is fine. We have good frameworks which provide us all required capabilities to create the cloud native applications. And with next slide, I would like to quickly go through by these frameworks like Quarkus. I believe you heard these interesting sessions about Quarkus. I just would like to highlight that this is very lightweight framework, has a good support to the cloud, and actually it's some kind of Kubernetes native framework which work very good with Java, because Java love the Kubernetes. He has very good boot time, and you need to understand that we already have new frameworks, not only Spring. I believe Spring is still the good one, but with this talk I would like to say you that we have another frameworks too. For example, again, Micronaut, also fast startup time, reduce memory footprint. Micronaut provide us minimal use of reflection, which, for example, Spring use everywhere. And in some cases, that's why our startup time between Micronaut and Spring application has some kind of difference between this startup time. And all these frameworks are using also leverage GraalVM approaches, which also has been provided us. For example, again, Helidon, also interesting framework, which was open sourced by Oracle. And initially, Helidon project has name G4C, Java for Cloud. And it's also another framework which provides us a lot of capabilities and allow us to build this cloud-native application and live in the cloud. And yeah, this is a big picture. And now I have shared and give you some kind of high-level information about the traditional approaches. I have shared you some information about what kind of frameworks we already have. I have provided you some information about why this evolution was a little bit late. But now everything is fine. We have everything to build the cloud-native application. And I just would like to provide several points how we can resolve all these limitations which we have during we use these traditional approaches. Like, do not forget about, again, cloud-native definition. Again, I will talk you it one more time. Cloud-native is some kind of world. And if you would like to live in this world, you should follow the rules. And these rules are our quality attributes, which I mentioned: loosely coupled, scalability, manageability, observability, and other things. And if we would like to build the Java applications, we should follow these rules. And to build such kind of application, we need to use the tools and frameworks. And we already talked about these frameworks, which provide us, they very lightweight, they allow us to create microservices, serverless approaches right now. And we shouldn't learn new languages anymore. And yes, if you would like to resolve this limitation, we can use these micro runtimes, microservices frameworks. But it's not if it's not enough for you, we have another options like adoption of distributed JIT and JIT caching. Does anyone already heard about these approaches? Cool. Idea of these approaches is that Java community, Java contributors come up with some kind of idea what will happen if we will take some kind of processes from JVM and move it to the cloud. And we will take this process, move it to the cloud, and start to use them as a service, as we, for example, using S3 bucket in AWS. if you need some kind of big storage or another service. And they have come up with these ideas. And let's also review these approaches and options of adoption. And first one, as I told, this is a distributed JIT, which decouples JIT compiler from JVM into the cloud. And if you need some kind of compilation, for example, it's provide us low memory consumption and low CPU spike when we start our application, because our code already compiled here, and we can go to the cloud and request these compilations back, and our application will be very fast during startup time. Very interesting thing. And this is not an idea. We already have vendors who provide these compilers, like OpenG9, Azul. Next one is JIT caching. And based on this application, you can see that if we'll use JIT caching and compare them with our frameworks, we see how JIT caching help us to improve the startup time, how it help us increase the time to the first operation. And initially, it was some kind of crack project, coordinate resource and at checkpoints. And idea of this improvement that we run our application all the time. And what will happen when we up our container and shut down? In this case, when we are running application, we have spent some resources for compilation, for runtime time, for warm-up time, for JIT optimization. And when we shut down our machine, our container, we lose all this work which we did during runtime. And idea was, what will happen if we will make some kind of snapshot of our machine at some time. For example, we have run our application, it was warm-up, optimization, something happened, and we creating a snapshot and move it to the cloud again. And when we shut down our machine, or for example, we need to scale our application, for example, add new instances, we do not compile our application anymore. We can go to the cloud and take this warm-up instance and use it. That's why we have this very fast time of first operation. And this is very cool. And again, we have microservices framework, which allow us to create native application. We have these approaches. Interesting thing here also regarding this and regarding this distributed JIT and JIT caching, that in this case, we can leave our code, our JVM, Java standards, which we are using right now, as is. For example, not all the projects able to split the application and create microservices, for example. And we can leave as is our application and warm up our some kind of create a snapshot of our application and take from the cloud. And in this case, when our customer come up and ask us to improve some performance of startup, we can use it. Very cool thing. And as can you see, we have different options, microservices and some kind of adoptions which we are already using in a JVM. And to sum up here, that do not stop learning anymore. I believe we use Spring everywhere, but Do not stop learning, because without learning something new and changing ourselves, we will not be able to change the world. And remember, Java is still great and perfect language. We have a lot of frameworks which provide us all needed capabilities. Just use them, learn them, and thank you. If you have any questions, please let me know.